morning. And I'm sorry if I have to pause to sneeze. My allergies are not great today. Okay, so our objective for math is I will be able to apply basic facts to solve extended multiplication problems. So a basic fact are multiplication facts that you already know, like 2 times 3, 2 times 2, 2 times 5, 5 times 8, 4 times 8, things like that, that you're already really good at. And now we're going to do extended multiplication and division problems, actually. So here's your math warm-up today. They are all division problems. So just a reminder of how to do division. Let's go over 30 divided by 6. So basically what we're trying to find is how many groups of 6 does it take to make 30? And so what you could do on your piece of paper to do any of these problems is you can make 6 groups. Always start with the smaller number, okay? And you're going to make 6 groups. 1, 2, 3, 4, 5, 6, like this, okay? And then I'm just going to count to 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So, and then I count how many are in each group. I count 1, 2, 3, 4, 5. So 30 divided by 6 is 5. If you have your 5's facts memorized, then you might have already known that. And then you're going to continue to solve for the rest. So 30 divided by 6 is 5. 40 divided by 10. 27 divided by 9. 49 divided by 7. 27 divided by 3. 81 divided by 9. 42 divided by 6. 54 divided by 9. And 63 divided by 7. Put your answers in the box, and please do this before moving on because this is your math warm-up and it'll get you started for your day. Back in 5, 4, 3, 2, and 1. The field day racetrack is 80 meters long. How many meters will the racers travel if they run the track 8 times? So 1 time is 80. 2 times, you add another 80. 3 times. So go ahead and solve. Try your best guess, and then move on to the next slide in 5, 4, 3, 2, 1. So you can efficiently solve multiplication problems with larger factors by applying strategies you have been using for basic multiplication facts. So today you will investigate strategies for solving multiplication problems when one of the factors is multiple of 10. That is, it can be represented as a whole number of groups of 10, such as 80, which is 8 groups of 10. So let's go back to this problem. What it's basically saying is that instead of thinking of 80 as 80, think of 80 as 8 tens. So when you break up 8 and 10, what you're doing is you're actually doing 8 times 8, and then you're doing that times 10, okay? So, or if you found that doing this, you did groups of 80 8 times, that's fine. You're going to get the same answer. So let's start off with something a little bit more easier, which is 2 times 30, okay? Some of you, it's pretty easy to add up 2 groups of 30. That is what 2 times 30 means. It means 2 groups of 30, okay? So this is 2 groups of 30 right here using the base 10 blocks. You remember the blocks that we have in our classroom. How many 10s are in each group? So look at one group. How many 10s are there? That means how many sticks, okay? And put your answer right here. Now you could represent 3 tens using base 10 shorthand or as 3 tens. Once I combine the groups, how many groups of 10 do I have? So how many 10 sticks do I have up here now that I've combined those two groups? And put your answer in this box. What is another name for 6 tens? So if I have 10 and 10 and 10 and 10 and 10 and 10 6 times, that basically means 6 times 10, which is 6 groups of 10. And so 6 times 10 would be what? And you're going to put that right here. Problems like 2 times 30 are called extended facts because a related multiplication fact can help you find the number of tens or hundreds or thousands in the solution. What basic fact can help you solve 2 times 30? What is something that is related to 2 times 30? If we're looking at 2 times 3 tens, okay, our basic fact is going to be 2 times 3. So if 2 times 3 is 6, and we have 6 tens, our answer is still going to be the same. So I'm going to show you guys how to do this because this one gave us the dots, the sticks, and the squares. The dot represents 1, the sticks represent 10, and the squares represent 100. So let's say I want to solve, and I need to show this, okay? So I'm taking these pictures and I'm dragging them over because I have a ton right here that I can use. So to solve 2 times 3, even though we already know it, okay, I still need to show it. So 2 times 3 is the same as drawing an array. I could do an array of 2 rows of 3, or I could do 2 groups of 3 and show it like that. Either way is going to be fine. So here's my 2 rows of 3. And so that equals 1, 2, 3, 4, 5, 6. So my answer is 6. Now I have 2 times 30, which is what we already kind of done. So I have 2 groups of 30. So this is 10, 20, 30, 10, 20, 30. All right, now how many 10s do I have now? 1, 2, 3, 4, 5, 6. So my answer would be 60. Now for this one, I have 2 groups of 300. So this equals 100. So I have 1, 2, 3. That's 1 group of 300. I need another group of 300. 1, 2, and 3. So now I have, now to solve, I just count my hundreds. I have 100, 200, 300, 400, 500, 600. Okay, so this is how you do this, a problem like this, and you're going to go ahead and practice yourself on the next slide. You're going to do 3 times 5, which is 3 groups of 5, 3 times 50, 3 groups of 50, and 3 groups of 500. What do you notice about the products in each set? So if you notice in this one, we do have a pattern. 2 times 3 equals 6, 2 times 30 equals 60, 2 times 300 equals 600. What is the pattern? And you're going to notice that if you did this correctly, you will see a pattern as well. What if we do not have longs or flats to use? For instance, if we don't have our sticks and our squares, well, we can draw them out. Or we could write them out, or we could just use those basic facts. What would these look like if we only had cubes? What would happen if we only had ones? Well, what would happen? And by the way, you don't have to answer any of these questions because I'm answering them for you. If we only have cubes, just like we did here for 2 times 3 equals 6, do you think I'd be able to solve 2 times 30 without using any sticks? I can, because 2 times 3 equals 6, 2 times 30, I'm just multiplying this by 10, right? And I'm just multiplying this by 100 because it's 300 now. So that is a way that I could use that basic fact and then have help me solve my next fact. So how can this pattern help us when estimating products? So let's say I have something like, well, like you guys have 3 times 50. So let's say I wanted to make an estimate of what that might be. So if I know what 3 times 5 is, I could know that 3 times 50 is going to be somewhere around that times 10. Okay? So here are a couple problems for you to solve. 3 times 90. What do you predict will be the product of 3 times 100? So one way that you could solve the first one is by going, okay, 3 times 90, I could use 3 times 9 and then multiply that by 10, okay? And what do you think the product will be here? All right, so go ahead and complete this slide before moving on. In 5, 4, 3, 2, 1. So 3 times 90 would be 270, okay? Because 3 times 9 is 27. You add a 0 at the end, so it'd be 270. 3 times 900 would be 2,700 because I added 2 zeros at the end of 3 times 9. And this makes sense because 900 is pretty close to 1,000. So let's say I rounded up and said, what's 3 times 1,000 would be 3,000. 3 times 9 being 27, I know that 27 is pretty close to that 30 mark. And 2,700 is pretty close to that 3,000 mark. Now, what do you think 210 divided by 3 is? How can we represent 210 with base 10 blocks? Remember that you can think of 210 as 21 tens. How can I divide 21 tens into 3 equal groups? Okay, so now you guys just practiced all of those division problems. 21 divided by 3 is going to be the exact same thing. So here I have 21 tens up here, and I could put them into 3 different groups. I want you to go ahead and do that right now. Pause the video and do 210 divided by 3 in 5, 4, 3, 2, 1. Okay, so now that you've done that, this is what I got. When I did 210 divided by 3, I got 1, 2, 3, 4, 5, 6, 7 in one group. 7 times 10 is 70. So 210 divided by 3 equals 70. So now it's your turn to solve. 320 divided by 4. 630 divided by 9. Now, your basic fact to help you is 32 divided by 4 and 63 divided by 9. Knowing some extended facts can help you solve other extended facts in the same fact family. For instance, if we know that 630 divided by 9 equals 70, then we know that 70 times 9 equals 630. Or 630 divided by 70 equals 9. So many ways you could do it. So, identify a basic fact that you can use to help solve the following extended facts and then solve. So 5 times 70 equals, the basic fact that I can use to help is 5 times 7. That's what I would expect you to put in that answer. So then my answer, 5 times 70, would be that times 10. Explain how you solved this. Okay, I'm about to run out of time. I will see you in a moment.